Now coming to the code, here adding the SSD1306 module is as same as the previous lecture, and interacting with it is same as like before. Now when coming to VL6180 module, what I have done is I try to gather a library where initialization of the sensor and also some default settings are present. I would suggest you to not to edit these settings, touch these, or I don't want to go very much deeper into this. Somebody if interested to go through the parameters of the sensor and settings, they can actually have a look at the datasheet of 6180 from ST. The main function that we usually use is the range function. This is the basic register where we tell the sensor to start the ranging, and I read the range from here. Rest of the things are the settings which we are doing through I2C. When coming to our main program, when you actually want to access the sensor, we just need to include the file that I have mentioned as it is without any change, and you can use this code while trying to access it. It is similar to the display access where we have binded the display to the I2C bus. Similarly, we will bind the LiDAR sensor to the I2C bus. Then we will pass the object to the sensor, what we have imported. Sensor is a function call or the method. I will pass the I2C object to it to create the LiDAR object. Now, as like we have accessed the display, we will try to access the LiDAR. LiDAR.range is the actual function which will return you the range in millimeter. Please note that when there is no object detected, the default range will be 255 mm. When there is an obstacle or a target near to it, it will return you the range in millimeters. In the while loop, first of all, I'll clear the display. I'll try to write the range in meters. Sorry, it is millimeters. And LiDAR.range will return me the range in millimeters in number. I convert it to string so that I can display it on the screen or the display SSD1306. I maintain two variables called current and previous. What I do is I compare my previous value with the current value. If suppose I have an approaching target or an approaching object, the value will be decreasing when some object is coming closer. That is what I monitor here. If suppose there is a sudden glitch, that means there is an obstruction and there is no object later on, and it is not a moving target, it should be displayed as glitch. Else it will be an approaching target. In the same way, if it is reverse, if my previous values are less than current values, then the consecutive values are increasing, then it's a moving away target. If there is no change, then it is no gesture. And I keep on update my previous value to current value so that it will be useful for the next iteration for comparison. Then I use display.show to show it. With this, you should be able to do successfully gesture recognition. Hope this explains you well, and it will be fruitful for you to use this sensor in any kind of application you come across with NodeMCU for Internet of Things applications. Thank you.